Hi all, in this video we are going to learn about maximum power transfer under DC circuit theory. Maximum power transfer. To obtain the maximum power from a network, the resistance of the load must be equal to the Thevenins resistance of the network. Thevenins equivalent circuit. So here this is our Thevenins equivalent circuit. Here this is RL or load current. The load current is a variable resistor. Here RL is the variable resistor, and here the RS is our Thevenins resistor, RTH. Vs means the supply voltage. Now to obtain the maximum power transfer, here RL should be equal to RTH. This is the condition to obtain the maximum power transfer. Now again we can use the Thevenin's current equation to obtain the current. Here the Thevenin's loop current I can be derived as here VTH over VTH mean Thevenin's voltage. Here Thevenin's voltage is Vs. So directly we can write Vs over RTH plus RL. As the same way we can obtain the equation for power. The power will be equal to I squared into RL. So here is the example question. Here for this circuit we are going to analyze the maximum transfer function by varying the value of RL. Here the RL is the variable resistor. We know the parameter RS is 25 ohm, Vs is also constant 100 voltage, but RL is the variable between 0 to 100 ohm. So by putting the different value for the RL, we can obtain the current I and P. And let's plot the graph and observe the how it is changing with respect to the value of RL. Now we know the value or we know the equation for the Thevenin's current. As we previously learned, I will be equal to Vs over Rs plus RL. For the power, we can use the equation P equal to I squared into RL. So by applying the value here, initially I am going to apply the 0 ohm for the RL. Rs is 25 ohm, Vs is 100 voltage. We will get the value for the I as 4 ampere. And if we use here RL is 0, then power will be also 0. So if we apply 0 ohm for the RL, we will get the current 4 amperes and the power will be 0. Then if we apply 5 ohm for the RL, we will get the current 3.3 amperes and the power will be 55 watt. Then if we substitute the value of 10 ohm for the RL, we will get the 2.8 ampere current and the power will be 78 watt. Then so on. Here we are applying from 0 to 20, then 25 to 100. Then the current is varying. Here you can observe that here from the 0 to 20 the current is reducing, then 4 to 2.2, then again reducing. So almost from 0 to 100 ohm the current is reducing, but here the power is from 0 to 20 it is increasing. Then here at the 25 ohm, here it is reaching the maximum value. After that it is again reducing. So we will analyze by plotting the graph. So it is the graph of power against load resistance. So here is the load resistance values and the y-axis is the power. So you can see that from 0 to 100. So here from 0 to 25, here the graph is increasing. At this point it is getting the maximum power transfer, At the RL 25, it is getting 100 watt power. That is the maximum power. Then by increasing more, it is reducing. The power is again reducing. So from this graph we can come to the solution that here we know our RS is the fixed value 25 ohm, but RL is the variable resistor. So when the RL reaches 25 ohm, it is giving the maximum power. Then after the power is reducing. So to obtain the maximum power, RS should be equal to the RL. So this is the condition to obtain the maximum power transfer. Transformer impedance matching. The maximum power transfer can be obtained even if the output impedance is not the same as the load impedance. This can be done by using a suitable turns over ratio transformer. So here is the transformer. By this transformer we can obtain the maximum transfer function when even if the Z out not equal to the Z load. So here Z out mean the impedance, Z out mean output impedance, Z load mean load impedance. So there is a equation here, Z out output impedance equal to NP over NS. Here the NP mean primary turns, NS mean the secondary turns of the transformer, squared into load impedance, Z load. So here by varying the value of the transformer turns ratio, the output impedance can be matched to the source impedance to achieve the maximum power transfer. I will show you with an example question. Here is another example question. If an 8 ohm loudspeaker is to be connected to an amplifier with an output impedance of 1000 ohm, calculate the turns ratio of matching transformer required to provide maximum power transfer of the audio signal. Assume the amplifier source impedance is Z1, the load impedance is Z2 with turns ratio given as N. So here the assumption Z out we need to consider as Z1. Load impedance we need to consider as Z2. So therefore here the N can be derived as square root of Z1 over Z2. So here the question is we need to find the value of N or the turns ratio. So here, so now we can substitute the value for the Z1 and the Z2. Here we know the value Z1 output impedance here 1000 ohm, Z load 8 ohm. Now we can again substitute for the Z1 1000, Z2 8. So here then square root of 1000 over 8. Again if we solve this, we will get the value 11.2 over 1. So this is the ratio of the transformer.